Assalamu alaikum class. My name is Amina Ashfaq and my roll number is 8. I am the student of MS Chemistry from UMT and I am presenting my presentation to respected Dr. Hammad Majeed. The topic of my presentation is composite materials. Here are the contents of my presentation: abstract, introduction, history, types, advantages, applications, and conclusion. Abstract. This paper is written by Rahul Reddy Nagavalli. It gives a brief introduction of the composite material. The research on the composite material should be enhanced further. Introduction. Composites can be defined as the material which consists of two or more physically and chemically different phases. Different systems are combined to achieve a system with more useful structural and functional properties. Here is the history of composite material. The first uses of composites date back to the 15th, when early Egyptian and Mesopotamia settlers used a mixture of mud and straw to create strong and durable buildings. The modern era of composites did not begin until scientists developed plastics. In the early 90s, plastics such as vinyl, polystyrene, phenolic, and polyester were developed. In 1935, Owens Corning introduced the first glass fiberglass. Fiberglass, when combined with a plastic polymer, creates an incredibly strong structure that is also lightweight. This is the beginning of fiber reinforced polymers industry. Here I will discuss the types of composite material on the basis of matrix constituents. The first level of classification is usually made with respect to matrix constituents. It includes polymer matrix composites, metal matrix composites, and ceramic matrix composites. Here is the flow chart of composite material on the basis of matrices. Composite material have basically three types. First one is polymer matrix composites, which is further subdivided into thermoset, thermoplastic, and rubber. The next one is metal matrix composites, and last one is ceramic matrix composites. Polymer matrix composites. The most common advanced composites are polymer matrix composites, consisting of a polymer which may be epoxy, polyester, urethane, reinforced by thin diameter fibers, which may be graphite, boron, etc. In polymer matrix composites, matrix is relatively soft and flexible. The reinforcement must have high strength and stiffness. Microcracks may form due to curing stresses or moisture absorption during processing. Metal matrix composites. Metal matrix composites, as name implies, have a metal matrix. Metal matrix composites consist of a metal or an alloy as continuous matrix and reinforcement that can be particle, shard, fiber. Matrices in such composites include aluminium, magnesium, and titanium. The reinforcement surface can be coated to prevent a chemical reaction with the matrix. Military and civil aircraft contain lightweight, high strength carbon and glass fiber composites. The next one is ceramic matrix composites. Ceramic matrix composites are composed of ceramic matrix and embedded fibers of other ceramic material in dispersed phase. Ceramic materials in general have very attractive package of properties such as high strength, high stiffness at very high temperature, and low density. The second category of classification of composite material is on the basis of reinforcement form. The second level of classification refers to the reinforcement form. It consists of fiber reinforced composites, particle reinforced composites, and structural reinforced composites. Here is the flow chart of composite material on the basis of reinforcement. First one is particulate reinforced, which is further subdivided into large particle and dispersion strengthened reinforced particles. And second one is fiber reinforced, which is further divided into continuous and discontinuous. And discontinuous is further subdivided into aligned and random. And the last category is structural, which is also divided into two types. First one is laminates and second one is sandwich panels. Fiber reinforced composites. Fibers consist of thousands of filaments, each filament having a diameter of between 5 and 15 micrometers, allowing them to be producible using textile machines, for example, in the case of glass fibers. The next one is structural reinforced composites. Structural composites are engineered products made from plastic, wood, glass, or carbon fibers materials. They have uh, some important properties such as high strength, high stiffness, low density. Its matrix consists of properties such as good shear properties, low density, and composite as a whole have properties such as high strength, high stiffness, good shear properties, and low density. Now I will discuss the advantages of composite materials. First one is lightweight. Composites are light in weight compared to most woods and metals. Their lightness is important in automobiles and aircraft, for example, where less weight means better fuel efficiency. The next one is high strength. Composites can be designed to be far stronger than aluminium or steel. Metals are equally strong in all directions, but composites can be engineered and designed to be strong in a specific direction. The next one is strength related to weight. Strength to weight ratio is a material's strength in relation to how much it weighs. Some materials are very strong and heavy, such as steel. Other material can be strong and light, such as bamboo poles. The next one is corrosion resistance. Composites resist damage from the weather and from harsh chemicals that can eat away at other materials. Composites are good choices where chemicals are handled or stored. Outdoors, they stand up to severe weather and wide changes in temperature. High impact strength composites can be made to absorb impacts, the sudden force of a bullet, for instance, or blast from an explosion. Because of this property, composites are used in bulletproof vests and panels and to shield airplanes, buildings, and military vehicles from explosions. The next one is design flexibility. Composites can be molded into complicated shapes more easily than most other materials. This gives designers the freedom to create almost any shape or form. Most recreational boats today, for example, are built from fiberglass composites because these materials can easily be molded into complex shapes, which improve boat design while lowering cost. The next one is non-conductivity. Composites are not non-conductive, meaning they don't conduct electricity. This property makes them suitable for such items as electrical utility poles and circuit boards in electronics. Non-magnetic composites contain no metal, therefore they are not magnetic. They can be used around sensitive electronic equipment. And next one is low thermal conductivity. Composites are good insulators. They don't easily conduct heat or cold. They are used in buildings for doors, panels, and windows where extra protection is needed from severe weather. And next one is durable. Structures made of composite have a long life and needed light maintenance. Now I will discuss the applications of composite material. They are applicable in appliances, construction, electrical distribution, and energy. Appliances, cooking, dishwasher, refrigerator, small appliances, laundry, ice machines. And in construction, it is used in entry doors, garage door, architecture, countertops, wastewater treatment. And in electrical distribution, uh, it includes breakers, motor control, centers, generators, switchgear, busway control cabinets. And in energy, wind turbine, fuel cell, solar panels, pumps. And it's the conclusion of my presentation. In a nutshell, the composites are the material which have many desirable properties and make them the best material that can be used in many applications. These properties make the composite materials replace the already existing materials which are used in present days. There is a wide scope of composite material in automotive, aerospace, wind energy, electrical sports, domestic purpose, civil construction, medical, chemical industries, etc. Any question? Thank you.